Wireless LAN. 1. Wireless LAN. Wireless LAN technology, which operates within a transmission range of up to 50 through 100 meters from the access point, has established itself as the preferred choice for office and home applications. Wireless LAN solutions are particularly convenient in the home, where two or more computers can enjoy simultaneous access to the Internet without the need for LAN cables. Wireless LANs are also used to provide convenient access to the Internet in the form of hotspots at Internet cafes and high-traffic public spaces such as railway stations. The three main wireless LAN standards currently in use are shown in the illustration. Wireless LAN systems use the access control system known as CSMACA, Carrier Sense Multiple Access with Collision Avoidance. Since wireless LANs do not have a mechanism for detecting collisions, CSMACA is designed to control the flow of data transmissions in order to prevent collisions from occurring in the first place. The figure above illustrates the basic principle of CSMACA. CSMACA control begins by determining whether other electromagnetic waves are in progress. If the channels are open, that is, if there is no other transmission, then permission for electromagnetic wave is obtained. CSMACA then waits for a fixed period of time plus a random period assigned to each wireless node before checking again for other electromagnetic waves. If the channels are still clear, data transmission may proceed. Note the difference with CSMACD, where transmission commences immediately if the transmission path is open. 2. Wireless LAN security. In a wireless LAN system, there is the potential for wiretapping via electromagnetic wave. WEP, wired equivalent privacy, encryption is used to protect data sent over wireless LANs. As the name suggests, WEP is designed to provide an equivalent level of security to wired networks. However, WEP uses short encryption keys, which means that during transmission of large data volumes, it may be necessary to use the same keys more than once. Data in which the same keys are repeated is considered potentially vulnerable to unauthorized decryption. This issue has been addressed in newer encryption formats, such as WPA, Wi-Fi Protected Access, and WPA2, developed by the industry group Wi-Fi Alliance. LAN-to-LAN connection. You can build a LAN to cover an even wider area by connecting a LAN with another LAN. In doing this, different devices are used, depending on the function level of the OSI layers at which both LANs are connected. One. Repeater. A repeater receives the analog signal, and then generates an exact duplicate of the original signal before sending it on. It physically connects two LANs, and is sometimes called a hub or a repeater hub. 2. Bridge. The bridge uses the MAC address, managed by the data link layer, in order to determine whether or not to forward the packet. It also regenerates the received signal in the same way as the repeater. The reason for this is that when the transmission source and the transmission destination are located in the same LAN, there is no need to pass packets to the next LAN side. In this case, the bridge does not relay the packets, and discards them. In addition to the bridge, there is a switching hop, which is a variant of the bridge that links several logical LAN segments and operates on the data link layer. It is sometimes called a layer 2 switch or a LAN switch. 3. Router. A router uses the address, IP address, managed by the network layer, and select the most appropriate route to forward packets through the network, routing. Therefore, the number of unnecessary packets passed through can be limited, and network congestion can be avoided. There is also a LAN switch that has functions similar to the router. It is often called a layer 3 switch in contrast to a layer 2 switch. 4. Gateway. A gateway can interconnect networks with different, incompatible communications protocols. It performs a protocol conversion function at OSI layers up through the session layer.